Fantastic. Hello there, Master Hellish here, and welcome back to my Feed the Beast Let's Play series here. And today I'm on my own because we're going to be doing a little bit of a different episode. Normally I would have Minecraft in full screen, but we have Minecraft on the right hand side of my monitor, and over here on the other side we have a web browser. And that's because if I'm working out how to do stuff in between episodes, playing around with things, I will have the Computercraft API screen open on my other monitor, and probably a Google page as well, so I can look stuff up. So we're going to look into how I work things out, kind of the in-between episode workings, although we're going to make an episode out of it. Since last time I've put some shelves up in my room. They have to be oak though, because for some reason you can't get them in any other wood, but you can't really tell that well from down here. There's a slight difference in the colour. We have our temp disk drive in this computer at the moment, and I want to know what's in it. So if I go into the disk, no, mistype, hang on, CD disk, press tab a couple of times, there we are, we're in the disk drive now, and if we do a dir, it'll list what, oh, is it empty? Ooh, our temporary disk is empty. Okay, that's cool. So that's alright. Let's get the programs disk in there and the temp disk. There we go. Right, brilliant. Put that away. So today we're going to eat some bread and we're going to look at how I might figure some stuff out. This computer here is connected via a network to this monitor here. But what I want to be able to do is I want to test to see if I can connect two computers up and do something with the files on each one. Now, I don't know if that's even possible, but I'm going to show you how I would try and figure it out. So I'm going to head over in here. We're going to need a couple of computers. Maybe, should we use advanced computers? What we got here? Advanced computer, yes. We can afford a couple of them. There we go, 2 of them. I'm also going to get an extra one and stick it in there. What's that? That's an advanced turtle. We don't want any of them. So we've got 2 computers. We're going to need a couple of modems. So we've got... Oh, we're a little bit short on redstone blocks. Let's see if there's any in the ME system. Redstone blocks. Yeah, we got... Oh, I don't want to take all of them. I'll take half of them. There we go. Generally, that's my general rule when I'm stealing resources for stuff. I'll only take half of what's there. So... 2 modems, and we need some cable, but I don't think we don't have cable in here yet. So maybe that's something that we ought to put in. We do have some project benches left over, so let's put that. Let's put it next to the modem. There we go. Now, how do I make cable? Let's have a look. No, if I search for cable, there's going to be a lot there. If I search for network, there it is, networking cable. Ooh, stone with redstone in the middle. Brilliant. I know we've got a load of redstone in here, so I'm going to take that. There we go. Redstone in the middle. Brilliant. I need some stone. Stone. ME system. Stone. There we go. There's some stone there. How much have I got? 64. Let's get a little bit more. There we go. And slap it in. I wonder how many... Oh, it makes 6. Oh, that's good. Let's make... Oh, I accidentally made all of it. Well, we've got some network cables stacked up for a while. I just need a little bit more stone now. What on earth was that noise? Let's just head up to the workshop and have a look. Use my lift here. Hey! Well, there's nobody here. Oh well. Okay, so we've got a lot of network cable now, 2 computers and a wired modem. I'm just going to put this back. Okay, so the stone is back in the project bench, and it's time to connect up our computers and have a look to see what we can figure out. So, first things first, computer. Then we're going to put another computer there. Just put them on the bench, why not? We're going to pop a wired modem on them. And we know how to use wired modems because we looked it up for making our... if I can just go around here. our monitor, which is actually turned off now because I think the server restarted, and we're going to have to manually start this again. So if I just come into the computer that controls that and do dir, it will say sign. So we're going to do sign. Oh yeah, that should be running the sign program now. Let's check. Originally we had it automatically starting up on startup. Yeah, IT department. So that computer and these monitors are hooked up by two wired modems and some cable. 8 pieces of cable to be precise. So we knew basically how to connect up. So there we are. There is a basic LAN network. Okay. Now we have to activate both modems. So computer 6 connected to network and computer 7 connected to network. Let's turn the computers on. Boot them up. There we go. Now, I want to put a file on one and then try and access it on the other. I don't know if it's possible, so let's do edit test 1 001. There we are. This is a test file. All right. So all this so far I know how to do, so I haven't really had to reference the internet at all. Oh, I accidentally ran that. I didn't mean to run that. I meant to just save and exit. There we go. So this is going to be our computer that we're going to access with this one. So for this one, we're going to go into Lua, which is kind of like the command prompt. Because, well, no, it is and it isn't. It has an operating system, which is OS, but you can actually go, yeah, I suppose it is like command prompt. Now, I have no way of knowing what I'm doing next, but I do know that I need to kind of reference this computer somehow. Now, if we turn this modem off and on again, you can see it's referenced as computer 6. So we could try and do that, but I'd rather wrap it up in a variable. So I'm going to look that up. So if we go on here and look at the peripheral API. Let's have a look. No, that doesn't look like. Let's go back to APIs. Peripheral. I'm not sure if it's peripheral. What about RedNet? File open. What does that do? Tells the computer that the side can be used for networking. Oh yeah, so that's sending and receiving of messages across the network, which we're not going to do today. Term allows you to write to a terminal screen. I thought it was peripheral. What about the modem? Let's look in the wiki for modem. Let's see, wireless ender and wired modems. Here we go. So this is how we create all the bits. Example, modem to peripheral. You see that we're calling a peripheral there, and we can actually save it and wrap it as a variable, and that's what we want to do. So you see, I've just been searching the wiki there, so I can now go. I know that you don't type the word local because of the way that the code works, and we found a bug in that previously. So we're going to call it. We're actually not going to wrap this modem up here. What we're going to wrap is this device, which is computer 6. So we're going to say C6, which stands for computer 6, is going to be equal to peripheral dot wrap. So I just do a W and then tab, and then we're going to say left. No, wait, no, not left. Computer 6, because if I did left, that would actually wrap the modem, which is on the left hand side. So let's just have a look at that. So if I had done left, this modem's on the left hand side of the computer, and that would have labeled this modem C6. We don't want to do that. We want to call this computer here. So there we are. We're wrapping it as C6. Now we can actually look to list what's on the network. So let's have a look to see if we can figure that out. Let's go back to the API screen and look at. Oh, I was looking at parallel. I meant to click peripheral. There we are. So we can actually do peripheral.get names, and that will give us a list of stuff that's on the network. Or it'll give us a list of peripherals on this computer, but the network kind of extends this computer. So if I do peripheral dot, so I press tab then, and I press G, tab wants N, capital N wants tab again, close the bracket. There you are. You can see that left is the modem and computer 6 on the network. Now let's put another computer on the network for playing around purposes. Let's do that. Okay. So I've got another computer. We're going to put the other computer up here on the top level. We'll put it there. Okay. We'll put the modem on the side like that, and we're going to connect it up to the wired network now. So we're going to put some cable here. And there we are. A couple of pieces of cable. It's actually a bad place to put it because I can't see what I'm doing very well. So I'm going to take that off. Oh my goodness, pickaxe. Use a pickaxe for everything in Computercraft. There we go. You can see that this one's not on. When I turn it on, it says computer 8. So now, if we do the same command at this computer that we just did for the get names, and to get that command up on the screen again, I'm just press the up key on the keyboard there. You can see it says left computer 8 and computer 6. So if this wasn't connected to a network at all, this computer, it would just tell you all the objects which are connected to its sides. But because the network kind of extends that, these computers become part of the peripherals of this computer. You could probably do something similar here. So if we enter Lua, type it correctly. There we are. If we enter Lua and do peripherals.g capital N names tab, there we are. So we get top, right, computer 6 and computer 7. I have no idea. Oh, it's actually picking up this oak shelf on its top. The right is the modem, and it's picking up computer 6 and computer 7. This is computer 6 and this is computer 7. You can actually interface with various different things, and I think maybe that's what we'll do in a future episode. We'll interface with some sort of power network conduit or something. Anyway, we've been messing around for a little while now, and we've got our little LAN set up here. We've racked computer up in the computer 6 in the variable C6. I'll tell you what, while we're at it, let's wrap up computer 8 in a variable as well. So we're going to call it, let's just press up a few times, go home, computer 8 as computer 8. There we are. Right, so now we've got two variables. Let's see, can we do a clear screen? No, won't let us. Well, we could type the whole command out, but I can't be bothered. Right, now I want to do some stuff. I want to look on here and see if I can get the directories. So normally, to get the directories, I would just type dir, and it would tell me that there's a folder called ROM and a file called test. So can I just call this peripheral by saying C6 and then do dir nil? What about that? You see, attempt to call nil. So it's not working. Okay, that is not how to do it. So I had a theory and it doesn't pan out. Let's check on here and see what we can do. So what we can do is calls a method on a peripheral. Wow, look at this. Peripheral.call string side string method. Okay, so I'm thinking this calls something on the other device. I think if no peripheral is connected, it returns nil. Oh, hang on, and return the values depending on the method being called. So let's see if we can call the dir method on the other computer. So C6, press tab. Let's try call. dir, is that going to work? No, attempt to call nil. What if we actually write out the full thing? So we do peripheral call, and then if we put C6 in here. Oh, no. There, C6. And then we do dir. Does that work? Ooh. Well, it didn't error. Peripheral.call 6dir. Right, let's try calling edit test 002. Let's see if we can get it to create a file. Well, no error. And no file. Well, that didn't work, did it? I'm going to do a little bit more reading and see what we... Oh, hang on. I just noticed this. Look, peripheral.get methods. There's a get method. Let's try that. So, no, let's delete that line. So, peripheral.get methods. This is going to tell us what we can do. Now, we can either do aside or C6. Let's try C6, see what happens. There we go. Well, we got nothing. We returned absolutely nothing back there. There's no methods on that. Let's try doing peripheral get methods left, because that's where the modem is. Aha! Open is open, close, transmit, is wireless, get names remote, is present, get type remote, get call methods remote. Ooh, let's try that then. So, get call methods remote. Get methods remote. So we're going to be that's a nice method to use, isn't it? Get methods remote. So let's see. Let's just do a Google search for Computercraft. Get methods remote. I'm not sure if get methods remote. There we are. So, wired peripherals computer. Somebody's asked a question here. Oh my goodness, look at this setup. Oh, that is really cool. Oh, that's a printer? We haven't even looked at printers yet. That'll be something to look at in a future episode. You can see here that he's doing mon peripheral right, and then right hello world. That's all cool. Somebody's asking some questions. I'm going to read through this and see what I can find. Okay, I've had a little read, and what I'm going to do is we're going to wrap our modem up in a variable. So let's get rid of all that. We're going to say mo for modem left, mol for modem left equals peripheral dot wrap left. There we are. And then mol. There we are. And we're going to not call remote. We're going to get methods remote. And I want to be able to see what we can pull back from that. Expected string. Oh, let's have a look back at the API. It says peripheral name. Oh, so do we have to do and then put our peripheral in, which is C6, our computer? Well, possibly, but well, we're not getting any errors. Get methods remote. Well, maybe there are no remote methods for us to pull back. Nah. Okay, I'm going to do some more reading. Okay, done a bit more reading, and there's some examples here about how you can call remote write on a monitor. So let's see if we can call a remote create file. Now, we tried to do this before, but we didn't do it out of our modem. So let's do it out of our modem. We're going to call the a remote method, and the remote method is going to go to C6, our computer. I think that's it. And then we are going to tell it to do a edit test 002. There we are. Let's see if that works. No peripheral C6. Ooh. Okay. That's something else for me to look at. What is going on there? Let's see if we have to do computer 6. Because we're pulling it through the modem. And I don't think that modem can see C6 because C6 is a local variable on our computer. So let's have a look. No such method edit test. Ah, right, okay. Let's see if we can get methods then. So if we can do get methods remote computer 6, because we can't use our local variable. Hey, look, turn on, shut down, reboot, get ID is on. So we can actually turn down and shut down this computer from this location. Now the weird thing is that I'd hoped that this test program would have been in this list of methods. So I'm going to do some more research on this side now and have a look to see if we can figure out how to either access new methods or... Yeah, I mean, those ones there, they're the OS methods. So if we go into the API and back to the home API page and look at that, there's .os.computer ID, not get ID. So it looks like the computer device may have some strange methods on it. Let's have a look at computer. So if we look down here, forces is shut down. You may be able to make programs turn on off Redstone, use RedNet, play games. The computer runs an OS called Craft OS. So we're looking for some methods. Maybe we can add some methods. Let me look that up. Okay, so my investigations have led me to this page here on the wiki, which allows me to see the API for computer. And if we look at the list of things that was on this screen... Anyway, why can't I access... Uh-oh, crashing. I'll be back. Okay, so the server has just crashed and is now offline. So we're going to do the rest of this episode in a test world. I have set up pretty much exactly the same situation of what we've got going on in my lab. This is computer 0, computer 1 and computer 2. On this computer here, if we do a dir, you'll see that we've got a test file again. And over here, I've done C1 as computer 1 and MoL as the left-hand peripheral, which is this modem. So we're in pretty much exactly the same situation as what we was before. So now I want to be able to get those functions. So if we do MoL get remote methods remote like that, it expects a string. So let's say oh yes, so it's looking on MoL. MoL is the modem. It's looking on that modem for any remote peripheral. We have to tell it which one. So computer 1. Don't forget the speech mark. There we are. So that's where we were before. And I was just about to say that this turn on, shut down, reboot and get ID is exactly the same here as the turn on, shut down, reboot, get ID and is on that I found on the wiki. This is the computer API. So if we go back to peripherals APIs, we'll see that there is a modem API. So you can see if the modem is open, modem is closed, is wireless, and we can get the names and all that sort of stuff from the modem. So we can actually call a remote modem and get the names of the things on that remote modem, which was a bit weird. And then, of course, there's the different APIs that a printer can have. However, none of these APIs seem to actually have anything that allows me to interact or execute commands on a computer. So I'm going to do some Googling, and I'll see what I can find out. Okay, I've done some reading, and we see this kind of information on the left-hand side here by this EMTK. So what we're going to do, we're going to change our test program into one that writes to the terminal. So if we save this now and exit and run it manually, so our test program, you'll see it says this is a test. Okay, so that is all good. So let's clear the screen and have a look at something else. What we want to do is, should we see if we can go into Lua and test this shell.run command? So we can do shell aliases. Let's try run. Yep, we can run. Let's see if we can run test 001. This is a test, and we get true as well. I don't know why we get true on the end, but that'll do for now. Okay, so what we'll do is we need to receive the message, and I don't know how to receive a message through RedNet. So it looks like what we have to do to actually do something on a remote computer is set up a program that will run that and receive the message and pass it through. This could be quite a challenge. I don't know what that is. It's annoying me. Get out of here. There we are. But let's see if we can just send a message using the RedNet then. Yeah, let's do that. So I've got the RedNet commands from the API here. There's the RedNet API from the wiki, and we're going to look at how to do this. So let's see if we need to open a port here. So we're going to go rednet dot open, and we're going to say right, because that is where our modem is, and we didn't get an error. So I'm going to presume that this modem is now open for communicating. Oh, it is. Look, there's a second red band on there. Oh, that's fantastic. So now I'm going to do rednet dot receive. Okay. Now, it says protocol filter is optional, number timeout. So the number is a distance / string. Wait until the RedNet message of a specified protocol has been received, or until timeout seconds have passed. Leave all arguments empty for any message to be received indefinitely. Well, that's what we want. Okay, so now this computer is just going to wait and do nothing until it receives a message. Right, now, let's have a look at this one. Well, I want to just get the RedNet, no, hang on, RedNet, and we're going to open the RedNet port on there for left, which is where the modem is. There we go. You can see that one's open for RedNet now. This one isn't open for RedNet, but it is connected to the network, which is quite cool. What if I shift click? Nothing. Control click? No, doesn't do anything. Right, let's disconnect it from the network now. So we've got two computers. Both are open. One is set to rednet.receive. So let's see if we can broadcast a message. So this, if we do a broadcast, it goes to all computers on the network. So, RedNet, a broadcast, and we're going to say, hi there, and go. Right, no errors, so I'm going to presume that that was broadcast across the network. Let's see if we received a message. We did. Hi there, 1. Now, I think the 1 is the code that you get from the computer. So we have successfully sent a message across the network, and we know that we can use those messages to kind of do special things. So we can kind of go, we can put a loop in a program. Let's just do, if we do, let's do it on this one. So if we do edit test 2, there we are, new program test 2. So we could do for, or we could do so while, or do. Is it do? So we want to do while. If for some reason I have a brain block like this, this is where I then come to Google and we do a search. So we're going to do Lua do while true. There we are, do while true, and it says just click on the first article, see what we get. If blah blah, then no, we don't want to if. I don't like that one. Let's try this one, a while. Ah, here we go, look, so it gives us an example. So while, there you are, it's in yellow in an advanced computer window. So we're going to say while true do, so it's an infinite loop. And we're going to say, well, actually, at the beginning of the program, we want to open the RedNet port. So we're going to RedNet open like we did before. There we are. So whilst we're truing, I don't want that. Get out of there. Do. There we are. We're going to do RedNet dot receive, was it? There we are. RedNet dot receive. And then we'll end the loop. So all this computer ever is going to do while this program is running is receive RedNet commands. But we want to do something based on that RedNet command. Okay, so we want to say if, and this is where I'm going back to here, to these notes here. So we're going to say we need to actually get that RedNet, we need to receive that RedNet command into some variables. So we're going to receive the ID into ID, and we're going to receive the message into MSG, okay, as the message. So we're going to say if the MSG, the message, is equal to, and when we compare strings in programming, sometimes there's a different equal to, and there is in this one. If the message is equal to, say, let's do say hi as one string like that, then we can then end the if, and in the if statement we'll do term dot print. Is it print? No, it's not print, it's write. Term dot write, and we'll say hello world. There we go. So this computer is going to open a port if it's not already open. Oh, hang on a minute. That open bit, we need to put which side it's opening the port on. So it opens a port up and it listens. When it gets a message, it checks to see if the message is say hi, and if it is, it writes hello world, and then it waits for another message. So we're going to save that. We're going to exit, and we are going to run it. So test2. Oh, equals expected on line 3. Let's edit that then. Line 3. Oh yes, look. We missed our equals here after our variable. Very well done. Quick correction, and then we're going to say run our test program. There we are. So that's now running. This computer is now listening on that port for any RedNet messages. So let's send it a RedNet message. Let's broadcast sleep. There we are. We've broadcast sleep. This one didn't do anything. We wouldn't expect it to. It hasn't been programmed to. But this one, it received that message but did nothing because sleep wasn't what we wanted. We wanted it to say hi. So if we rebroadcast a message and we say hi, that message has now been broadcast to all the computers, and this computer's program has now gone, hello world. Well, there we go, folks. That is how I figure things out. Not normally in this world. Normally I'll do it in my bunker. But I'm going to continue playing around with this and work out how we can do various different things. And it may be that we end up writing a program that we constantly run on our computers to accept lots of commands from a core central computer. But we'll see how that goes. That is how I work things out. That is my method in thinking, and that's how I look up things on the internet through the APIs, the wiki, and general Googling. Thanks for watching. If you've got any thoughts, ideas, or questions, pop them down in the comments below. It's always been a bit of a long episode, but I hope you'd enjoyed it, and if you have, please consider giving it a like. Thank you, take care, and goodbye.